Good morning, dear students, and welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. Now, so far, I've given you an introduction to physical world, how our reality is based on physical laws. Now, currently, this session, I shall provide you the bridge course of mathematics to your current 11th and 12th syllabus. So why is it necessary for me, as a student or as a lecturer or as a physicist? So why is it important to learn mathematics for physics? Now, the only language that physics explains the whole nature, the nature of our reality, is by mathematics. So to provide you a bridge course, which is a connection from your high school to your college. So there's a gap which is left out in between. So I'm going to fill in the gap where you get a proper continuous connection from your high school mathematics to your college level mathematics. So this is actually a session 1 of a bridge course. It would be a basic arithmetic and basic trigonometric functions. So let's get started with the first arithmetic, which is rational numbers, quite important when it comes to discussion of set of real numbers. Now, when you've already learnt in lower classes a number line, a line that is extended on both the direction towards the right as well as to the left. A line that extends, let me change that color to a different one. A line that extends towards the right hand side and towards the left hand side. When I say a line, it means this particular line is extended towards the infinity. So onto this set of lines, I can represent numbers on them. Now the numbers that you have learnt in your lower classes, starting from your first standard, are the natural numbers. Natural numbers given by the capital letter N, which consist of the numbers 1, 2, 3, 4, 5, and so on and so forth. So you start counting from 1, 2, 3, 4, 5. Have you ever wondered why actually do you start counting from 1, 2, 3, 4, 5? That's because the objects around you start with set of all natural numbers. If you need to count the number of trees that are outside, very scarce, especially the current world that we're living in, we are running out of resources, which means we're chopping those trees down for our sakes, for our set of resources. So which means you can actually go ahead and count the number of trees. It's become that scarce, especially in a city like Bangalore. So a set of natural numbers consist of 1, 2, 3, 4, 5, and so on and so forth. And then moving on, after your primary school, which is your lower classes of first standard, second standard, then you'd have move on to the next, which is learning set of whole numbers. I think by first and second standard, you must have encountered the set of all whole numbers as well, where whole number starts with the number 0. And then you have set of natural numbers that accompanies as 1, 2, 3, 4, and so on and so forth. A number starts with 0, 1, 2, 3, 4. So where have you noticed a number that is starting from 0? And why do we have to start a number from 0? Now, if you take a scale, or in your ruler, you have set of measurements that are located. So the first number, what you observe is 0. Have you ever wondered why is 0 actually written? That is because 0 is kept as a reference point. So you start the measurement from a reference point which is at 0, and then you make the following measurement as 1, 2, 3, 4, and so on and so forth. So set of all whole numbers itself given by the letter W. And then moving on to the next standard, which is your 5th and 6th standard, you must have encountered, which is integers, given by the capital letter Z. Set of integer consists of positive natural number, negative natural number, and a 0. So a 0 which is at the center, and then you have positive numbers located in one direction, and then the negative. And this carries so on so forth, the side and toward line. Will it be at far extreme right hand side? Will it be far extreme left hand side, or somewhere in middle? So you'd say it's somewhere in middle, which is 0 located here. And towards the right hand side, you will have set of all positive integers. These are called positive integers, and these are called negative integers. Positive integers are 1, 2, 3, 4, 5, and so on and so forth. And for set of all negative, welcome back students. So what we were discussing here is number line, set of integers represented on a number line. Set of all positive integers along the right hand side, set of all the negative integers along the left hand side. So this is how you represent set of integers. Next, probably when you were in high school, then you would have learned a rational number. So what is a rational number? Any number that is written or in the form that is P by Q, where Q particularly should not be equals to 0. Now what happens? Have you ever wondered what happens? You must have asked this question to your teacher. If not, then you must. It is a necessity that you need to ask your teacher the question, why is Q not equals to 0? If a number which is written of the form P by Q, where Q is not equals to 0, why shouldn't it be equals to 0? Now, you may also try this in your calculator. Just type in a number and divide it with 0. What you obtain there is an error. It shows you with the letter E in the corner of a calculator. So why does an error occur when you specially divide a number by 0? Now that is because any number that is divided by 0 is actually not defined. So any number, let's say 1 by 0, this number is not defined. It really makes no sense dividing any number by 0. So we just say not defined. Now if you go on with the long division method, which you actually use in order to divide a given number, 0 divided by 1, and if you go on dividing, then you would say 0, 1 times is still 0 and you get 1. Hey, I still got the number 1. Then again you would say 0, 1 times is still the number 0, which is still 1. And this number carries so on and so forth, which really makes no sense. So that is why we say any number that is divided by 0 is really not defined. Sometimes it is given by this symbol, which is infinity. But that is not the accurate symbol to use for a given number that is not defined. So I would suggest you write ND as an abbreviation for a not defined number. Okay. So particularly here, so these two numbers, which is P by Q, called the rational number, where Q is not equals to 0, it should not be equals to 0. P and Q are actually set of integers. Now you may say, Q, if it is an integer, then it must have the number 0. So here I've made the condition where Q should not be equals to 0. Apart from Q not being equals to 0, it can have any other number on a given integer line. So let's have a look at few examples of the form P by Q. Oh no, I seem to have erased it all. Okay, one more time, where P by Q, where Q is not equals to 0. Let's write few examples of those numbers. Let's say 1 by 2. 1 is a positive integer, 2 is also a positive integer, 1 by 2 is a rational number. Easy, very simple. How about minus 1 by 2? Is this a rational number? Certainly it is. This is also a rational number, minus 1 by 2. Because minus 1 is an integer, 2 is also an integer, therefore it is a rational number. Then how about the number 2? Is this a rational number? Now you may think hard, you may think twice, because any number that is written of the form P by Q, but you do not observe a number Q. You observe only a number that is assigned for P. So what will be the number for Q? By default, the number for Q in such cases are 1. So therefore, this also is a rational number. If that is such the case, so what about this one? Put a little bit of smiley there. Yeah. What about this one? The number 0. Is this a rational number? Yes, it is. It can be written 0 by 1. You may argue and say, sir, a number should not be equals to 0. But here you have set the number as 0. Certainly not. Yes, students, welcome back once again. So, like I was saying, conducting set of operation on rational number. What are the different operations you can use for a given number? Now, if you're a biology student, then the concept will be entirely different for you. Though our discussion is more of based on mathematics, the set of operations that you might have learnt in the high school or in the lower standards are addition, subtraction, multiplication, and division. So 4 basic simple operations that you know how to conduct. So let us conduct those operations for a given rational number. Let us first add 2 given rational numbers. Let's take an example of 1 by 2 minus 3 by 2. Oh, plus, since we're adding. Since the denominator is the same, which means they're of a like fraction, in a like fraction, all you have to do is add the numerator. So numerator would be 1 plus 3 whole divided by 2, which is equals to 4 by 2, which is equals to. But what if it's more of an unlike fraction? Unlike fraction, meaning the denominators are not the same. So let's take a look at an example, which is 1 by 2 plus 3 by 4. Denominators not the same. How would you add these two numbers in such case? Now, first thing what you need to do is turn this denominator into the same number. So how do you turn it into a same number? Using the concept that is called LCM, lowest common multiple. So what exactly is a lowest or a least common multiple? Let us take the multiple of 2, because we have 2 and 4 in the denominator. Let's take the multiples of 2. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth. Let's take the multiple of 4. 4, 8, 12, 16, have I 16, 20, 24, 28, 32, and so on and so forth. Lowest. Now let us find the common multiple first. So what are the common multiples of 2 and 4? Common multiples are 4. Let me use a different color for that. Okay, I'll use a different color. Red. 4, and then 8, 12, 16, and so on and so forth. You can find those common multiple. Among these common multiple, which is the least common multiple? The least common multiple is 4. Therefore, the LCM of 2 and 4 is 4. A very simple trick. How to find LCM? Multiples of 2, multiples of 4. The least common multiple of those two is your LCM. So which means LCM of 2 and 4 is 4. Now that you have found the LCM, you have to turn this denominator into the number 4. We already have one such number 4 here, but we have to turn this 2 into 4. How will I change this 2 into 4? Very simple technique. All you have to do is multiply it by 2. Now, if you're conducting any operation to the denominator, such as a multiplication in this case, then you also need to multiply the numerator by the same number. So, next, 2 by 4 plus 3 by 4, you have like fractions, meaning they have the same denominator. You add the numerator, which is 5 by 4. So this is how you add two such rational numbers using LCM. The same thing can be done for subtraction of two rational numbers. Let's take the case of 1 by 2 minus 3 by 2. Subtract the numerator because the denominators are the same. 1 minus 3, and 1 minus 3 is, and that is how you obtain the answer minus 1. Let's take another case, but this time the denominators are different. So go ahead and try this and tell me what the answer is. Okay, try, give it an attempt. 3 and 6. LCM of these two will be, now you may complain, it's too lengthy process writing all the multiples, and therefore you have what is called as a bracket method. The other method, what you use is a bracket method where you write 3 and 6, and then you use prime factors, prime numbers. I hope you remember what is prime numbers. If not, you can go ahead, take your first standard, second standard books and try to read up on what's a prime number. Very important, but don't be ashamed. It's something to learn. So 3 1 times, 3 2 times, and then you have 2 1 times. The multiples are 3 and 2, which gives you the LCM for 3 and 6, which is equals to 6. So LCM of 3 and 6 is 6, which means you multiply this by 2, multiply this by 2. This you need not multiply because it's already a number 6. So which means you get 2 by 6 minus 1 by 6, which is equals to 2 minus 1 is 1 by 6. Easy? All right. Now moving on to the next operation, which is multiply. How do you multiply two rational numbers? Let's take the case of 1 by 2 times 3 by 4. Multiplication is very easy trick. All you need to do is multiply the numerator and multiply the denominator. Multiply the numerator. 1 times 3 is 3. But the sign, as you notice, on one side it is minus, the other side it is plus. Now there are sign multiplications that you learn. Sign multiplication where you have positive times the positive equals to positive. Positive times negative equals to negative. Negative times positive equals to negative. Negative times negative equals to positive. So these are what are called as sign multiplication. Okay, so I hope you get it. It's not too visible as well. Okay, so you have negative times the positive. Negative times positive, sign multiplication is negative by 2 times 4 is 8. One more, we'll try one more. Minus 1 by 2 times minus 1 by 2. Minus into minus plus. 1 times 1, 1. 2 times 2 is 4. This is how you multiply two rational numbers. Let's have a look at another operation, which is division of rational numbers. Let's take one such rational number, 3 by 2 divided by minus 2 by 4, which is 1 by 2. Or let me write it as 2 by 3. 2 by minus 2 by 3. Division is also a very simple trick. The trick that it involves here, let me show it step by step. First you write the dividend, which is 3 by 2. The next part, what you need to do, change the division into a multiplication symbol, and as you do that, you need to reciprocal the given divisor. So reciprocaling meaning you have to change its position from denominator to numerator and numerator to denominator. So which becomes minus 3 by 2. You see? Sign from division to multiplication, and what happens to the two numerator and denominator is they switch places, and when they switch places, we call this process as reciprocal. And then you multiply, and multiplication is a very easy technique which gives you 9 by 4 as a result. Easy? So these are set of rational numbers usually given by the capital letter Q. Now there are also the other set of numbers which are called irrational numbers. Now irrational numbers, you may or you may not have learnt it. Nevertheless, you will be learning them in your 11th and in your 12th as irrational numbers as a separate chapter in mathematics. So I'm not going to break that surprise for you. Let it remain as it is. So rational number and irrational number. Irrational number usually given by a capital letter I. So rational number and irrational number together is what makes up real numbers given by the capital letter R. So what are real numbers? Real numbers are those when you draw a number line, all those individual numbers which you place them, not just your integers, not just your whole numbers or natural numbers, not just your rational numbers and irrational, but a combination of all these numbers which are represented on the number line are what are called real numbers. So real numbers includes fraction, it includes decimals, it includes your rational numbers, it includes irrational numbers and many more. Okay, so these are real numbers. Now there are also other type of a number line which are called imaginary numbers. I am not going to break that surprise for you again. You have other set of number lines. Okay, so you have one number line which is visible, which is known to us a fact that it exists. So which are called real numbers. There is also a number line which is imaginary, which does not seem to exist, but it does, but you cannot see. So it becomes an imaginary number line. So again, that will be discussed in this syllabus, which is mathematics of class 11 or class 12. So moving on, let's solve a question which is based on rational numbers. Question here is, there are n books in a library. 4 students have decided to take the books on a particular day. The first student takes half of the books, the second student takes 1/4 of the books, and the third student takes 1/5 of the books. And the fourth student gets only 7 books. How many books are there in the library? Pretty easy question. All you need to do is understand what the question actually means. So what you need to find is the number of books. How many books have been taken? How many students have taken the books? 4 students. And where does it specify? Here. There are 4 students who have taken the books. How much did the first student take? He took 1/2 of the books. The second student takes 1/4 of the book. Third student, 1/5 of the book. And the fourth student takes only, or he gets only 7 books. So now the library is empty. Pretty small library. You will soon see the number. So 7 books are obtained by the fourth student. So how do you solve such question? Now it is already known to us the total number of books in the library is the total number of books in library is equals to, so that is what we have to find, but it is given as n. So we will write it as n. N to be the total number of books. Out of this n total number of books, half the book is taken by 1 student. So which means half of n taken away by the first student. Next, plus second student takes 1/4 of the book. So which is 1/4 of n. Similarly, plus third student takes 1/5, if I'm not mistaken, 1/5 of the books, and the fourth student takes only 7 books. All this number of books will result to total number which is equals to n. So now what we have to do? We have to find the value of n. So here you have 1 by 2, 1 by 4, 1 by 5. Notice in the denominator, there's 2, there's 4, there's 5. So what would be the LCM of all the three? LCM of 2, 4, 5. Quickly go ahead, find out 2, 4, 5 LCM, 20. So since the LCM is 20, we multiply this denominator. Let me choose a different color. Into 10, so that 2 times 10 is 20. If I'm multiplying the denominator by 10, I have to multiply the numerator by 10. Similarly, 4 times 5 is 20 times 5 to the numerator. 5 times 4 is 20 times 5 to the, times 4 to the numerator. That looks odd. Times 4. Okay. So go ahead, try to solve. Find the value of n. So you get 10n by 20 plus 5n by 20 plus 4n by 20 plus 7 equals to n. Okay, I'm erasing this so that I get more space to solve. Now, for those of you who are already following, and if you have missed this, you can go back and have a look at it. You can review this video at any possible time, your convenience. So 10 plus 5 plus 4, that's because the denominators are the same. Now 10 plus 5 plus 4 is total of 9. 19n by 20 plus 7 equals to n. What you do next is take this, transpose it to the other side, and when you do that, you get 7, which is equals to n minus 19n by 20. Now, here the denominator is 1, LCM is 20, so you can go ahead and write times 20 times 20. So 7 equals to 20n by 20 minus 19n by 20. 20 minus 19, how much do you think it would be? 20 minus 19. Go ahead, solve. Very easy. 1n by 20. Transpose this to the other side where you get 7 times 20 equals to n. So n will be equals to 140 books. Like I told you, a very small library which consists of 140 books. All right, let's have a look at another question. Sum of the horizontal and vertical rows are the same. Find the missing rational number. This is the missing rational number. So sum of the vertical and the horizontal are the same. Sum of the vertical is 8 by 31 plus 6 by 31 plus 4 by 31. Oops. 4 by 31, which is equals to 6 by 31 plus 6 by 31 plus x. So I'll call this as x. Denominator the same, so 8 plus 6 plus 4 is 18 by 31, which is equals to 6 plus 6 is 12, 12 by 31 plus x. Transpose this 12 by 31 to the other side, so you get 18 by 31 minus 12 by 31 is equals to x, and 18 minus 12 is, where x is equals to 6 by 31. So the missing number is 6 by 31. All right. If that is the case, we move on to the next question. This one is quite interesting. All right. Find the distance between A and B. You have 0 and you have -1. A is located here and B is located here. What is the distance between these two? Now first, we need to see how many parts from 0 to 1 has it been divided into. How many parts? So let's have a count. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, there's 8, there's 9, and there's 10. So how many parts? 10 parts. Still, no sir, I don't believe you, that's 10 parts. Maybe your counting was wrong. Let's have a look at it by how many parts that exist. That's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts. Okay. Now that 0 to 1 is cut into 10 parts, we will number those each and every single part. All right. Starting with 0. So you're going in a negative direction. So make sure your numbering is also negative. So the first one will be -1 divided by 10 because it is -1 out of 10 parts. Then -2 by 10, -3 by 10, -4 by 10, -5 by 10, -6 by 10, -7 by 10, -8 by 10, -9 by 10, and -10 by 10, which is equals to -1. Now that we have all the parts, determine the location of B. B's location is -3 by 10. So B's location is -3 by 10. A's location is -9 by 10. To find the distance between the two, you need to subtract one another. So let us subtract, that is B minus A, to identify what is the distance AB. B minus A, B is -3 by 10 minus of 9 by 10. -3 by 10 minus of minus is plus, as you had noticed in the sign multiplication. 9 by 10 minus 3 plus 9 is 6. Denominator is the same, so 6 by 10, which is also equivalent to writing 3 by 5. So that is the distance between the two, A and B. Okay. So let's have a quick look at the time, because I don't want to extend it. Can I have the time as to? Okay. So I think we will end the session here. In the following session, I shall discuss with you about trigonometry ratios, how important are trigonometry ratio, how to identify different trigonometry ratio, which would also be the bridge course for your class 11. So I will see you all in the next session. Until then, everyone, take care, have a nice day. Bye bye. See you all in the next session.